So page circles handout. Page 30. Okay, let's say B and F. Just B and F. B and F. Okay, so moving on. 2.2, linear equations in one variable.
Is that B?
Yes, B and F. Linear equations in one variable. Let me refresh our memory on those two equations that they are very familiar, I'm sure. Y equals mx plus b, and y minus y1, mx minus x1. Slope times x minus x1. Any questions? Yes, please.
I don't have circles kind of.
Nobody does. It was a 35-page long. I did not copy it. It's in Canvas. So there is a folder with all these handouts. Some of them I have copied for you, but some others I didn't. I didn't want to copy a 35-page document and just use 3 problems.
What's the name of that folder?
Circles. I wrote it here, right there. Circles. Circles handout.
Right.
Circles. Okay, so can anyone refresh our memory on the names of these two equations? So this is point slope, and this is slope intercept. Very good. It should be clearly specified slope y-intercept, but we know what it means. So it's slope intercept. Very good. So I like to determine the equation of a line, either parallel or perpendicular, or find the equation of the line given 2 points. I'll let you choose. For now, please let me know. These are, again, other rational equations. I don't think we should go back. I think we finished with rational equations. These are recommended by the coordinator of this course, but I think we already have enough. But if you want to choose, we can. But what I would like to look at is either parallel or perpendicular, which I will refresh your memory in a minute, and given 2 points to find the equation of the line. Let's start with that. What about 35? So we have, or you can give us any point. You would like to choose a point, 2 points, or you want to use 35. Doesn't matter. 35, okay. So we have -1, 3, and 4, -5. So we're asked to find the equation of the line passing through these points. Find the equation of the line. I don't want to just repeat myself all the time. If you have any questions, please always raise your hand. It's not considered an interruption. I may not ask you every 3 minutes, do you have questions? Do you have questions? Please don't be shy and just ask, okay? Okay? Perfect. So we're asked to find the equation of this line. And we do have y minus y1 equals the slope times x minus x1. We will be using either point. It doesn't matter. But what we don't have is the slope. So let me refresh our memory. Y2 minus y1 over x2 minus x1 is the slope. Steepness of the line. Now, how come that I don't use this? Why don't I use y equals mx plus b? Well, the reason is that b is the y-intercept, and it has to be an ordered pair that has 0 for x. This is the y-intercept. If it doesn't have 0, for the coordinate of x is not 0, then the x coordinate is not 0, then it's not the y-intercept. So you shouldn't bother with this. Even if you have the y-intercept, you can always use this one as well. But this is obviously easier. So I'm going to name my points x1, y1, and x2, y2 again, and carefully replace them. -5 minus 3 over 4 minus negative 1. 4 minus negative 1. So then the top is negative 8 and the denominator is 5. So we found the slope of this line as being negative 8/5. And now we have to replace everything, regardless of which point you would like to use, in the point slope form. Okay, so then I'm going to use the first point. So y minus 3 equals negative 8/5 x plus 1. Let's take a moment. So I replaced y1 by 3 and x1 by negative 1. I would distribute negative 8/5 and move negative 3 to the other side. I have to solve for y. Can anyone dictate the next step? So y minus 3 equals negative 8/5 x minus 8/5. We distribute negative 8/5 to x and to 1. And then we add 3. So y equals negative 8/5 x minus 8/5 and plus 3. We have to add these two. I recommend the following steps, like exactly what we just did today and last time. Negative 8 over 5 plus 3 over 1. The least common denominator is 5. Same thing, the adjustment for the top of the second fraction is 5. And we have negative 8 plus 15. Exactly what we did with rational expressions. We find the least common denominator and then we find the necessary adjustments for the top. The only adjustment needed was on 3 because this one has the same denominator, so I didn't have to do anything. So then the answer is 7/5. If you keep and use the same method, and if you understood that method, then you will never make a mistake. Or use your own method. So this is the equation of the line passing through the given points. Always tell me whether we need another example. Do we understand the steps? How to find a slope and how to plug in. Okay, perfect. Now let's talk about any questions from me, please. Always stop me if you need more time or only, yes, please, go ahead.
So if there was a line intercept, we would use point slope for the slope and we would use.
Yes, so if I have the point, if I determine the slope, let's say negative 8/5, and one of the points is 0, 3, I would write immediately y equals negative 8/5 x plus 3.
And one of your.
Okay? Yep. But none of the points was the y-intercept, so I didn't use that. Other questions, please? Okay, parallel, perpendicular, lines. The parallel lines, M1 must equal M2. So two lines are parallel if the slope of the first is identical with the slope of the second line. For perpendicular lines, this is the slope, this is the line with slope M1, and this is this line with slope M2. The relationship between the two slopes is not the same. They're not the same. How do you remember it? And then I'll tell you how I remember it. Okay, then I will tell you both ways. M1 equals the negative multiplicative inverse of the other, which will take me 5 minutes to say it. I prefer it cross-multiplied, and I say the product is -1. It's up to you. They mean the same thing. The first one, the top one is what we are taught. The second one is what I like to remember it by. I say the product is -1. If two lines have the slope, if I multiply the slopes of two lines and I get the answer -1, they must be parallel, perpendicular. There is no other way. So now let's look at a problem. Like 29 on page 100 from your book. And the question reads, find the equation of the line using the point slope formula, write all the final la la la. So I doesn't say, they should have whatever, connected it to something. But anyway, perpendicular to this line and passes through the point. So we are given two pieces of information here. The first piece of information, it says it's perpendicular to 3y equals x minus 4. This is the symbol we use for perpendicular. And passes through the point -2, 1. So this is the idea. This is just the idea. We are asked to find the equation of this green line. And we know two things about it. We know that it's perpendicular to a line whose equation is 3y equals x minus 4. And we know that somewhere along the line, there is this point, -2, 1. I did not graph any of the lines. I have no idea how the lines look like. This is just the idea. So I'm asked to find the equation of the green line, knowing that it's perpendicular to the purple line and it passes to this point. So I have a point. So I will, which is or is not the y-intercept? Is not. So I will be using y minus y1 equals the slope times x minus x1. And I know that I have the point. It's right here in front of me as 1, -2, but I am missing the slope. Yes, please.
Why are we using that one?
Because I don't have 0, a number.
Okay.
I use the y. So this, very good. Let's take a look. So this equation is useful only when I am given a point that is the y-intercept, 0, a number. If I'm not given a point that is 0, a number, I can still use it, but it will be like me doing this instead of this. So it's still possible, but it's convoluted and there's no, yeah, I'm not going to do that. If you know how, please go ahead and use it. So we're not given the y-intercept, so we're using y minus y1 equals the slope times x minus x1. Okay, what do we do with the slope? How do we find the slope? Say it again.
y2 minus y1 over x2.
Excellent, but I only have 1 point. Yes.
-3.
Um,
M1 into M2 equal to -1.
True, but we have to explain how we get that. What do we need to do? Yes, please.
Find the slope of the other equation.
That's it. Let's find the slope. Oops, I swallowed the L. Find the slope of 3y equals x minus 4. How do I find the slope of this line? Remember, the first form is still very useful. Because if I solve for y and everything on the other side in this correct sequence, right, descending order, I will be able to identify the slope of any line. So that's exactly what we're trying to do here. We are solving for y. So then y equals 1/3 x minus 4/3. Please do not write a long fraction line and 3 at the bottom. Please divide everything by 3, step by step, term by term. Because we want to identify the coefficient of x. If you just draw a long fraction line and put 3 in the denominator, it's not going to help. So comparing to mx plus b, comparing this to y equals mx plus b, we are able to identify the slope of the given line. So let's call this one m2, which is 1/3. Everyone with me? Any questions? Is this okay? Can you keep up? Please tell me if you can't, okay? Or if you need more time. Okay, now, knowing that the two lines are perpendicular and knowing that the slope of the purple line is 1/3, we can determine the slope of the green line knowing the relationship between the relationship between the slopes of two perpendicular lines. Or you use this one. If one of them is 1/3, this one must be -3. Only -3 times 1/3 is -1. Or you can put 3 here, you put 1/3 here, and then flip it, and you get -3. Do we understand why M1 is -3? M1 is -3. So now we have all the information we need. One more time, do we understand why the slope of M1 is -3? Everyone? Okay, so do you understand the slope of this is 1/3? Okay, so the question is 1/3 multiplied by which number is -1? So the answer must be -3. There is no other number that we multiply 1/3 by to get -3. That's one option. The other option will be M1 equals the opposite, the multiplicative inverse, the negative multiplicative inverse of the given slope. So when you flip this, you'll get M1 equals -3. Is this better? Excellent. Good. So now we have all the pieces of information. We have to put them together. Y minus 1 equals -3 times x plus 2. Careful. Minus -2 plus 2. So we distribute -3x minus 3, and we bring 1 over. So y equals -3x minus 2. Can anyone tell us what does -3x minus 2, y equals -3x minus 2 represent? It is the equation of the line that is perpendicular to 3y equals x minus 4 and passes through.
Wouldn't -3 times 2 be -6?
I was supposed to point that out.
I'm sorry. Sorry. I'm sorry. My apologies. Yes, it's 2. It's not 1. Okay, sorry about that. So my apologies, -3x minus 6 plus 1, yes. So it's the line that is the equation of the green line that is perpendicular to 3y equals x minus 4 and passes through -2, 1. How are we doing so far? Are we okay with this? I would like to graph one function. Any questions for me? Any questions for me? Okay. So, yes, is this okay? Do we need other examples, or can we move on to graphing a line? Okay. I would like to graph a line, and it is required to use x and y intercepts. Please move away from graphing the line using the slope. I know it's useful. I'm not disregarding the method, but the x and y intercepts are what we need at all times. Okay? So, problem 41 on page 85. 41, page 85 book. We are given an equation. 3y equals -2x plus 6. And we're asked to graph using x and y intercepts. X and y intercepts. How do I determine the x and y intercepts? Please.
You could set like y equal to 0 and then solve for x and x equal to 1.
Okay. Yes. So sorry about that. X equals 0. All you have to do is just cover it. How much is y? Bless you. 2. Y is 2. What is the ordered pair that we just determined? Y is 0. Just cover it. But you have to move negative 2x now. So 2x equals 6 makes x equals 3. So from here, x equals 3. And the ordered pair that we just determined is 3, 0. Very good. We plot the points. 3, 0, 1, 2, 3, 2, 0, 2. Connect the line and extend. Connect the points and extend the line. Please write the name somewhere. We graph 3y equals negative 2x plus 6. Any questions? Any questions? Any questions? Any questions? Yes? Okay. Can we move on? I'm looking to see if I missed anything, if I forgot anything. Okay, so let's see where we are so far. So back to this handout, you have it. Yeah, this is in your syllabus, so you have it. So we accomplished the 1.6, so you always know where we are, and I also need to know where I am because I know we are all over the place with all sorts of handouts. So 1.6 and 2.1, linear equations in one variable, and we looked at several examples from here. And now we will move on to 2.3, models and applications. And we are going to look at the supplement with equations, and you do have that. I gave that to you. I just have to find it. I got it. So it's this supplement, and it has a few problems at the very end. So this one, supplement modeling with equations. It's a tiny one, just 3 pages. When we will be finished with this, we will continue with 2.6. I doubt that we can get to it today. However, we made a huge stride because we finished this one. We did it last week and this week. Last time and today. It's already last week for me. Okay, so we made a huge progress here. So I'm trying to stay on track, if possible. Okay, so here is our section 2.3. Modeling with equations, basically. 2.3. And what I would like to accomplish here is look at these 3 problems. Why? Because you're going to see these problems again in calculus. They've been adopted from our calculus book, actually, because I'm just teaching that. So in another class. So in a calculus class. So I would like to select a couple of problems from the book first, and then finish the class with those problems from the handout. So this is on page 109. I would like us to solve some literal equations for a variable. That's one thing that I would like to do. Like, for example, this problem or this problem, 39, just to get the feel of how to solve a literal equation. So let's start with 31. And this is on page 109 from the book. So we are told that the sum, and we are going to look at this at the end, towards the end of the semester, sum 1 minus r, this is little r, lowercase r, is the formula for an infinite series sum. And again, I promise you will get to that. And I'll show you how we get it. If the sum is 5, find lowercase r, which is the ratio. So if the sum is 5, so then 5 equals 1 over 1 minus r. We're asked to solve for r. See why we had to, and I'm going to tell the coordinator, we had to solve rational equations before getting here. I couldn't wait till section 2.6 to show you rational equations. We couldn't wait till then because this is a rational equation, right? And it's a proportion. How do I solve a proportion? Exactly. However, before I do that, I have one step that I have to perform. Mandatory. I have to write. Exactly. Because if I try to write restrictions after I cross multiply, there's nothing to write restrictions on. It's gone. The fraction is gone. So that's cross multiply. 5, 1 minus r equals 1. I will prefer dividing both sides by 5. 1 minus r equals 1/5. I prefer the variable on the left-hand side, but it doesn't matter. You can move this and then move 1/5, but it's not important. Remember how we add or subtract fractions. Find the least common denominator and find the adjustments. Now, if you want to multiply by -1 first and say 1 minus 1/5, it's also good. So it's up to you. And 1 minus 1/5, if from 5 over 5 I take away 1 over 5, then r must be 4/5. So now I would like your help to choose. 32, I can enlarge this for you to see better. So 32, 34, or 39. I'd like to illustrate with one more. Oops, sorry. So 39, we're solving for lowercase h. 32, we are solving for w. Or 34, and we are solving for f.
39.
Very good. 39 it is. Sometimes I teach a couple of sections of the same course, and it's so interesting when I ask my one group, what would you pick? And then I ask the second group, and they pick the same problem. I have no idea why. It was very interesting. Okay, 39. 110. Page 110 from the book. A equals 1/2 h in parentheses b1 plus b2. Anyone remembers this? What it represents? It's the yes, please. Okay. Trapezoid. Trapezoid. Big base plus small base times the height divided by 2. Big base, small base. Good. So this is the area of a trapezoid. We're specifically told to solve for h. In other words, we don't care about anything else, just assume everything else is a number. Don't even bother with it. So what would be the first step, do you think, here? Yes, please.
Multiply everything by 2.
Excellent. Always try to simplify things. And this is an equation. I don't need a fraction in there. If I could get rid of it, why not? So I am going to get rid of it by multiplying both sides by 2, and we get 2a equals h b1 plus b2. And there is one final step, and it's done. We're solving for h, doing what to both sides?
Dividing everything by B1 with B2.
Whatever, that parenthesis, exactly, and it's done. Exactly. So these equations, yes, any questions? Did I do something? Did I say something? We were laughing. We want to laugh with you. Okay, so these were literal equations. I see 1, 2, 3, 4 variables in here, but we are specifically told you have to solve for h. So we are solving the model for h. Any questions? Any questions? We need more problems, or can we move on? Is it a yes? Is that a no? Move on. Okay, so I'd like us to look at these problems that are recommended here at the end of the supplement. Please take a note, make a note of what is in here, because there are some examples and solution. Example 1, example 2, example 3, and all of them have solutions. So you can read those when you can, and please do so. So let's start with so these are problems 1 through 3 from the supplement, modeling with equations supplement. Modeling with equations supplement. And then we can put that aside as well. Okay, so let's read the first problem. A spotlight on the ground shines on the wall 12 meters away. From the first sentence, I know this. Agreed? This is what I picture immediately after I read the first sentence. A spotlight on the ground shines on the wall 12 meters away. Here's the wall, here's the spotlight, and 12 meters. A man who is 2 meters tall is standing directly between the spotlight and the wall. Okay, he is 2 meters tall. I cannot draw a man, I'm so sorry. Okay, let's say this is his head. Okay, so he is standing directly between the spotlight and the wall, somewhere, I don't know where. It says, part A, if he is 3 meters from the spotlight, okay. How far up the wall does the shadow go? I'm going to graph this one more time. And say this is 3, this is 12, therefore this must be, not that we really care, and this is 2, and this is x. So we want to find x. How far or how tall is his shadow on the wall? Anyone remembers or thinks of anything, any concept from the past adventure in math that comes to mind?
Similar triangle.
Thank you very much. Both triangles are right triangles. The tiny triangle and the pink triangle are similar, not equal, not congruent, but similar. Similar triangles. The concept of similar triangles is very important because if two triangles are similar, we can write proportions with their sides. But I have to convince you that these are similar. I cannot just tell you these two triangles are similar and I'm done. I have to convince you. And in order to convince you, I have to show two sets of equal or congruent angles. If I show you two sets of congruent, I don't have to show you the third one. Because if two sets are equal, the third one must be equal as well. So I already showed you the fact that they are both right triangles. That's one set. And the second set is it happens that this angle is common. So one is they are right triangles, and the second condition is they have a common angle. Because of these two reasons, the small triangle is similar. This is the notation for similar. Similar to the big triangle. I just didn't want to put letters in there. Because I can show that these two angles are equal or congruent, this is a common angle. Therefore, this and this must also be equal or congruent. Now, it's very important how we write proportions with their sides. Because they are similar, therefore, we can write proportions with their sides. This is what is useful for us. This is extremely important. But you cannot just write proportions in any way, with no order. Here's how we write the proportions. So therefore, we can write proportions with their sides. Okay. I recommend the top, let's say the small triangle. Everything that we are going to put in the numerator comes from the small triangle. Everything we're going to write in the denominator is coming from the big triangle. But in a particular order. Here's the order. Let's start with the common angle. What is the side that is opposite to the common angle in the small triangle? 2. So then we write 2. Still with the common angle. What is the opposite side in the big triangle? X. We are moving on to the next angle. This is the next angle. Back to the small triangle. What is the side that is opposite to this piece, to this angle, in the small triangle? 3. We are still with the same angle. What is the opposite side of this angle but in the big triangle? Equal to 12. Now when I move to the right angle, I don't know this, and I don't know this, and I don't even care for the third one. Because I already have what I need. What is this? This is a proportion. How do we solve a proportion? There is no need to write x not equals 0 now. Why? Because x is a distance. Otherwise, I would have. So now we cross multiply. That's why we reviewed proportions. So this is 24 equals 3x, or 3x equals 24. So x equals measurement unit. Excellent. So please remember the measurement unit is extremely important. So this was part A of the problem. Any questions for me, please? Part B of the problem. If his shadow goes 7 meters up the wall, how far from the wall is he? So now, in part B of the problem, we have 2, 7, 12, and how far from the wall is he? X is this piece. So this is still 12. And this piece will definitely be 12 minus X. All I have to do is go back to the proportions. So 2 divided by equals, it was 3 over 12. 3 over 12. But now it's 12 minus X over 12. Is that clear? So let's do this one more time. We start with the common angle. So then the opposite leg or the opposite side of the common angle in the small triangle is 2 over the opposite side from the big triangle, which is 7, equals. So now we are looking at these angles. The opposite of this angle is 12 minus X. Same angle. The opposite of this angle in the big triangle is 12. Okay. Again, this is a proportion. What do we do to solve for X? Yes, every time we have to solve a proportion, we'll cross multiply. If we need to state restrictions, we'll state restrictions first. But there is no need here. There is nothing, no X in the denominator. So 24 equals 7, 12 minus X. You can distribute or divide, whatever you want to do. You want to distribute or divide, doesn't matter. 12 minus X. So then I will move terms around. I will move X to the left and then the other one to the right. So remember, we need adjustments because 12 is over 1. And that is 84 minus 24. Am I correct? So 84 minus 24 is 60 over 7, and the measurement unit, whatever that is, measurement unit is in meters. Any questions? Any questions? I know we're down to 6 minutes. We're going to start problem 2, and we can finish it next time if we are not able to today. Any questions on similar triangles? Remember, the key is to identify the congruent angles and have all sides coming from one triangle at the top and all sides coming from the other triangle at the bottom, but in a specific order. Be very careful. Okay, and let's look at number 2. A grain bin that is shaped like a cone point down is 12 feet deep when empty. Okay, so this is problem 2, handout. Modeling with equations. And it is 12 feet deep. And the diameter at the top is 8 feet. Okay, so then the height is 12 and the diameter is 8. So I'm going to write my notes, 12 feet, and the radius is 4 feet at the top, of course. The bin is filled with grain until is 2 feet from the top. So something like this. So this is 12, this is 4. And this piece is 2. And it's filled up. The bin is filled with grain until it is 2 feet from the top. What is the volume of grain contained in the bin? Let me refresh your memory on some formulas. The volume of a cylinder, this is not a cylinder, but the volume of a cylinder is the area of the base times the height. Why am I referring back to this? Because the volume of a cone is 1/3 of that. So if you remember the area, the volume of a cylinder, pi r squared, area of the base, pi r squared, times the height, then you will remember the volume of a cone as being 1/3 of that. So I am not missing the height of the grain. What is the height of the grain? 10 indeed. So I know that this is 10. But what I don't have is this piece, which is the base of the cone that has grain in it, not air in it. So I'm missing this piece. This is, I'm going to call it uppercase H because I don't want it to be confused with this one. Or I'll call this one uppercase H, and then we use that. You know what I mean. I meant R, of course. Right? Good. So again, we are facing the same situation from before. I know I have 2 minutes left. So let's just determine the radius. So I want to find this. I know that this is 10. I know that this is 12. And I know that this is 4. Same situation. 2 right triangles. The small one and the big one. I start with a common angle. And the proportion will be R over 4 equals, and now I continue with this angle, 10 over, please find a radius from there and put it in